All right, welcome everybody. Come on in. I'll start sharing my screen so you know that we're in the right place. Well, welcome everybody to our webinar, and we're really excited to be here, really excited to do this webinar, and there's really a story behind it. In fact, we were talking, we'll call it in the green room, about why we're doing this webinar, ProMax for non-engineers. CleanConnect and PureWest Energy, we're users actually. Well, I'd say CleanConnect, we're definitely users and we use it in a special way. But we try to explain what we're doing in terms of our empirical journey, and we talk to an audience, and Kelly and I were just talking about that, how it's so different. When we say we use ProMax and here's how we're using it, and someone in the audience knows what ProMax is, they nod their head and they're like, yeah, that sounds great. And then there's a bunch of people in the audience who said, hey, what's ProMax? So we thought it would be important to do a webinar where we're saying, all right, let's explain what ProMax is and why it's important. And that's why we're here. So listen, if you're in the right place, if you want to discover PureWest's journey to empirical measurement using ProMax, top 7 benefits of using ProMax, or 7 ways that PureWest is using it, how to transition to empirical Subpart W using ProMax, and why nat gas buyers are willing to pay a premium for emissions data validated with ProMax. So I am here with my great panelists here. So Kelly Bott, Senior Vice President of Corporate Affairs. Welcome, Kelly. And
morning, everyone.
And then Jason Oates, a VP of Environmental and Regulatory from PureWest. And then Diego Morales, consulting engineer from ProMax, or Brian Research and Engineering, BR&E. And then my name is Mark Smith. I'm the co-founder of CleanConnect, also the author of the EPA cheat sheet, and I also have a podcast as well. So I'm going to let Diego take this away and get this, like, what is ProMax? And but also, before we also go, there's a little story there about how Jason and Diego met. But I'll explain what ProMax is, and then how you guys got connected.
Yeah, sure. So big question here. What is ProMax? Well, ProMax is a type of software called a process simulator. It's used in the oil and gas, chemicals, and energy industries. And it's used for designing and optimizing process facilities and performing engineering calculations. Take it up to the next slide.
Okay.
And yeah, so okay, it's a software. It does engineering calculations. What exactly can it do for me? So we're taking readily available data from samples, operating conditions from the field, and we plug it in. Now, from this data, we calculate expected emissions from a facility, reconcile, say, the inputs and the outputs leaving the facility. So that's technically a mass balance there. So you're basically, what if you're measuring what's coming out? Okay, well, you know what's coming out, maybe in a volume standpoint. Maybe from context clues what's coming in, but everything in between, what's going on there? Well, ProMax can help solve that problem, right? What's coming out at the end, what's coming in at the front end, what's going on in between? What are all the components at each point in the process? And say, like, what for leaks, for instance? What if you had a pipe leak? It's a big deal. If you get a pipe leak, if you get a big emission point there, I think under new rules, super emitter rules could get pretty bad. So ProMax can help you to basically show the time duration, what particular components and how much methane escaped from the pipe. It's pretty nice. And you can't really do, say, your emissions inventories or optimizing your operations by changing set points. You can't really do that in an accurate and highly efficient time or a highly time efficient way without a process simulator like ProMax. So I remember there was this one time I was sitting there was this pizza bar you had mentioned, Mark, and it's old Chicago, I think, in Casper, Wyoming. And yeah, I was just sitting watching maybe some baseball game or something, and drinking my beer, eating my pizza, and right next to me was this guy. Didn't have too much hair up here, but he was just sitting to my right, and I think he noticed my Aggie ring. He's like, "Hey, what's that?" Yeah, I went to A&M. We started talking about what we do, and he works for PureWest. He does environmental type stuff. I'm like, "Oh, how's that going?" Well, man, I'm having this problem with I can't figure out what the mass balance is. And I was like, dude, you got to use ProMax. So that's how we first met. But yeah, I'll let them take it away from here.
Yeah, because next up will be, well, I did put this slide together, and Jason, you can chime in there about the pizza visit there, but not your
Yeah, it was
typical
a great
bar
visit. It was funny.
conversation.
You don't find too many people that know about mass balance sitting next to each other in Wyoming, but it turned out to be a serendipitous meeting, of course.
So, Diego, typically ProMax is known by engineers. It's used by engineers when they're designing, brand new sites design. I've been in many meetings with operators and the regulators, and it's part of the output, right? So it goes in with a permit, and the output of a ProMax design is saying, hey, this is how this site will operate under normal conditions, or when now they've got a site exists, but they're going to upgrade it, maybe add a tank battery, add a bunch of other stuff. They go back and update the ProMax model, and the output is, which is pretty much, as far as I know, accepted by every regulator in the United States. Would
Sure, yeah. That's one of the biggest use cases for ProMax, right? Your initial design of your facility. Now, what happens if this environmental factor from outside changes or something inside the process changes? What's the output going to look like now? What would the emissions look like now? And how much oil are we going to produce, for instance? We answer those types of questions. Read vapor
Mhm.
pressure. What's the read vapor pressure of my oil in the winter, right? All sorts of things like that. Yeah.
All right, so we'll be getting into these other five uses in the presentation, but first I'd like to hand this over to Kelly, talk about the vision and mission of PureWest so we get an idea of who PureWest is.
Sure. Thanks, Mark. A little bit about PureWest. So we're the largest natural gas producer in the state of Wyoming. In 2021, we rebranded. We were Ultra Petroleum, became PureWest, and really leaned into this concept of environmental and safety responsibility and made that our really primary focus. When it comes to the ProMax work, we had done a tremendous amount of work on top-down emissions and emissions monitoring. Our leak rate is really low. Our leaks are very small, and so when we started that work, we were really trying to identify leaks and quantify our emissions. In 2022, we joined the Oil and Gas Methane Partnership, and so got very informed about reconciliation, and so really turned our attention and added that as one of our primary objectives. You can go ahead and go to the next slide, Mark.
Okay.
Just a little bit about kind of where we operate. We're in the Upper Green River Basin in southwest Wyoming. We've got about 3,500 wells, primarily federal land. We've consolidated the field over the last several years. So we've got several vintages that were built by various operators. So when it comes to designing a field-wide monitoring program, we've got a lot of challenges out there. We've also got things like sage grouse, which makes installing new power really problematic and really challenging. And so we've got some headwinds, but we're working through it. And I think we've arrived on a solution that really works for us. So back to kind of our work on what's your next slide, Mark?
Yeah, got OGMP and these things. Yeah.
Great. So I won't hit on this one too much. I really want to talk about how we kind of arrived at this ProMax solution. So we had been doing this top-down work. We were having, not entirely successful results at leak identification, certainly. But when the ProMax work came up, we realized that maybe our focus should be on that bottom-up inventory. So when we talk about reconciliation, it's really important to have that bottom-up inventory developed so that when you're doing the top-down reconciliation, you're working from a good starting point. Up until this point, we had been relying on EPA emission factors. We know they're fairly punitive for PureWest. And so this was really important for us. And so what the ProMax work does, and we're rolling this out to our entire field, what the ProMax work does is it gets us a really, really accurate bottom-up inventory. We're shown about plus or minus 3% accuracy just in that bottom-up inventory. And what that enables us to do then is prioritize our pads based on risk so that we're installing the best tech on the high-risk pads. We're going to have some pads that probably won't warrant having any kind of monitoring tech, and that's okay because we've got this ProMax work. But what it does is it enables us to do reconciliation with metal oxide sensors or laser-based sensors. We've got the CleanConnect stationary optical gas imaging camera that pans our facilities and actually helps us identify leaks. So those high-risk facilities will probably warrant something like that. But it really all starts with the ProMax work. So I'll stop there and see if Jason, if you have anything to add.
No, I think you covered it all. I think that's a very good introduction to where we were. So yeah, Mark, I think explain kind of the conundrum.
Yeah, so the conundrum, right? So you started on this journey, what, 2-3 years ago? I mean, going down this path? Okay, well, I think because of Subpart W, people really feel like they're at a crossroads. Do I just keep doing emission factors, and believe whatever the EPA tells you to believe, or do I take the red pill and I discover that, the truth about what's actually happening? And, as in the Matrix, it says, and I show you how far the rabbit hole goes. But really, drawing the new Subpart W using the red and the blue pill analogy, the blue pill is kind of like the factors, right? So what we had before was factors, which they now call measurement method 5. They added this thing in there for periodic LDAR, and they call that measurement method 4, so you can say, well, hey, this leak didn't happen for an entire year. It happened to the last regulatory manual LDAR, so let's say 90 days ago, and then cite specific factors, okay? Now you take the red pill and you're over here with this idea of direct measurement. And there actually is a chart from Subpart W that says these are things that we believe could be directly measured. And then this concept of combo, direct and cite calculation. So if you have some direct measurement, you can use calculation, and they literally specifically call out ProMax in Subpart W and saying, well, this, you don't know this directly, but you know it because you've made the model live, so to speak, which we'll talk more about. And then if you have these 1 and 2, you can actually back into a key thing that we mentioned before is mass balance. So that's really when you start heading down this path. Now, when you talk about where the Subpart W and this emission thing is in the overall thing, so the current Subpart W, or the pre-empirical, was the equivalent of OGMP level 3. And then OGMP said, well, you got 2 more. Okay, now I want you to measure your source level and then measure your site and reconcile the 2. Now, MMRV, which is a brand new thing with 18 countries who put together this measurement method, US is part of this, as a way to common measurement for LNG, for example. And so this is getting to be a very sophisticated protocol. It's evolving quite rapidly. But as you can see from this diagram from the MMRV group, that they really intended this to be an ecosystem where buyers and sellers could trust the data. And that's a real key factor here. Plus, they're using a lot of ISO certifications and stuff. So I actually plotted this out where I compared the new Subpart W, okay? And I compared it to OGMP level 2, 2.0 level 4 and 5, Colorado's new GHG intensity reporting, and MMRV. And I did this in terms of complexity. So, and I put these little green highlights to say that there's some new innovations here. So Subpart W added this method 1 through 5, and they added the WEC fee, which I don't know if calling that an innovation, but that's something new, right, to deal with. And then a site and source level reconciliation, that's an OGMP, that was sort of their innovation. Colorado has a site and source level reconciliation as well, but they have a baseline that actually decreases, so it gets harder and harder over years to actually hit the baseline. And MMRV has many of these things, but where it added innovation was on specific ISO audits that you can then hit to prove that you're actually doing the things in the emissions inventory. So that's another different thing. So whereas with these emission inventories, you turn it into the EPA, you turn it into OGMP, you turn it into Colorado, but here you don't turn it in, you get it third-party audited. So that's a difference there. Now, this is just an illustration purposes only, but what I've been hearing from operators is that the WEC fees are going up. So let's say 2024 numbers, is $900 per ton, and maybe use the old factors, and you're good, no WEC fee. But in 2025, they increased the factors. So now, without changing any new throughput at all, you might be over the limit, and now you actually owe, and then in a future year, the fee goes up and you could even owe more. So the question is, can I just stay on the factors? Yeah, but you'll probably end up paying a higher WEC fee. So, so what we've done is we've come up with a suite and we have parts of our software that deal with each of the departments within a company. So engineering, HSE, ops, and what we're calling our Prove Zero, but this would be like the sustainability group. So we have software that will help with emissions inventory reporting, with compliance on Quad OBC. We have a digital twin system, which I can show you. We have all of these different things for ops. So gas and liquid leak, autonomous gate guard, fire smoke, tank level monitoring, and essentially the beginning of a remote monitoring management system, and then the ability to create a tokenized tradable energy certificate. So now I'm going to talk about really the next thing, in real-time operations, performance monitoring. And the way I do this, we have this process called M4, and these are the kind of things that we set up for each client. So we help set this thing up for PureWest. So we do have a digital twin system. And this comes into play. We actually built this originally because we would go physically out to a site and put a tower and a camera. And then when you start looking at its optimal location, you're like, oh, wait, it'd be better if that tower moved over a little bit. Well, moving a physical tower is not an ideal use after it's built. So having a virtual system where we could place a tower virtually and then see what the camera would see ahead of time is a huge boon to the engineering side. But in our next version, we're actually tying it in with the ProMax model so that, when the camera sees something, it not only sees an object, it knows what that object is and all the physical characteristics of it. We have a camera system. So this is important, in the monitoring side. Okay, and we have 3 different cameras, this is one of them. But from this one camera, we can do all of these different detections, gas leak and liquid leak, fire smoke, gate guard, tank level, and so on and so forth. We then put the camera physically on a site, and then we can make tweaks to the pan, the tilt, and the zoom, and also we can draw objects around components. So when we actually see a leak, we can tag it directly to a specific object. And you'll see a few leak examples coming up here. You see tanks overpressuring. And, again, we can see this works day or night. Here's one from 4 a.m. at 300 feet away. So we can see objects that are leaking. And we start to detect them, and we then can measure them as well. Okay? So if a detection comes in, you can actually take over the camera, you can pan, tilt, and so you can look right at that object. And this is great. Instead of having to get in a truck and drive out to a site, you can literally take control of the camera, even if it's 3 hours away, and really zoom in and find out what's going on. The way it works is our cameras are tied into an edge device. They connect to SCADA, and they come up to SCADA, so you get alerts that way. And this is where we hook ProMax on. So you're getting feeds right off of the SCADA data, and they go into the platform, and this is what you saw where I can configure the dashboard and get alerts that way. We did get government approved for our autonomous LDAR with Colorado, and we're going through that same process at the EPA level. But we had approved source level detection, blind testing, LDAR equivalency. There's an alternative work practice, operator endorsement, and we got EPA Region 8 for Colorado, and now we're going for the whole EPA. And when you get an alt-aim approval letter, it basically says, hey, if you use CleanConnect, it replaces regulatory, in this case, Colorado's monthly LDAR, AVO inspections and tank emission monitoring. And that really reduces the scheduled call outs. And it has an alternative workflow that we built in so you can AI detection, assist with diagnostics, a repair system, and then you can verify repair. And this is what we're talking about today, the bottoms up measured inventory that gets created out of all this. And then we can use that data to retrain the model. So what we're going for with the EPA level is a periodic screening at a component level. We detect anything, then you comply with 5397B, which is a component level live look, and then we do a remote component level inspection. So component level screening, component level inspection, all remote. We also have hard hat detection, so we detect, humans. We have the virtual gate guards, so we can see trucks, read license plates, log all that information, allow you to tag it, whether it's an employee, a contractor, a regulator. We also do fire and smoke detection. Another example of smoke detection there. And because of that, and we built that out, we now have a Method 22 feature that's rolling out. So that's going to save people a lot of time in setting up the Method 22, smoke inspection type thing. We also have liquid leak detection, and all of that goes into a dashboard. So it's a unified dashboard with all those different leaks and all your different locations. So now that sets up monitoring, and I needed to set that up because now we'll get into the measuring part where we talk about the new feature in ProMax 6 called data exchange. And so I'll tell you why we do it, and then I'm going to turn over to PureWest, why they were excited that we were using ProMax. But for us, it allows us to take that model. In many cases, operators were using ProMax to get their permit. Then they took that model and it sat on some hard drive. It wasn't being used. And we're like, wait, let's take that model and update it to be as built. And then now, if we tie it into the live IoT data, and we'll show you how that's done, you can get real-time mass balance. We can use it for site level reconciliation. We can update, like I said, we update it to as built. We link it to IoT data. We can now link it to a digital twin. And it just helps create a continuous feedback loop to improve our AI machine models as well. So PureWest, I'll let you jump in with the why ProMax.
Yeah, I think the biggest thing, from our perspective, is understanding when you get a number from a monitor that's monitoring a site, how do you know where that's relative to everything else? And so the ProMax at least gives you that, thermodynamic chemical engineering approach to, the first principles approach to getting that number of here's at least what the expected emissions are from that site using the real data from the actual operational picture that's going on, plus the all of the design parameters that are built into each piece of equipment, and so running that multiple times in a simulated fashion over a period of time gives you a really strong I think defensible number to say this is at least what we think it should be. And then the monitors then help to prove or disprove that, or show you where there could be some anomalies. And over time, that's where that you continue to improve that model. And we found some really big improvement areas because we were able to finally see where the data was taking us and what was driving those numbers. And we'll talk about that more in a minute. But the big thing was the ProMax name, being that it was already accepted by EPA, had credibility, and I think the process and the procedures that they go through to get these numbers and to prove that it's already being used in those, and so it had that defensibility factor as well.
Yep. And so I'm not going to get into the details here, but the first thing is there is a chemical engineering formula for mass balance. And that boils down to what meters and stuff you are tying into. So when we first do this, we say, okay, what meters are available on that site? The G tester and different meters like that. Okay. Then, we then map those into the ProMax model. So now you're getting real live telemetry data mapped into a ProMax model. Again, as I mentioned, it's right here. So we're tying that in, and we're tying that in the back end. So it's a little different. This is not your typical like engineering license. All the ProMax models for all of our clients are running on the back end, with CleanConnect, and we're handling all that, those requests for our clients. Now, here's a little we'll call marketecture drawing. Okay, so our computer vision, and we're looking for fugitive leaks. But now we tie in the IoT data, and we're tying it right into the ProMax via data exchange. And now we run that all together through our AI machine models, and now we get other things. So we get the fugitive, we get the non-fugitive emissions, what it's doing, and we get the mass balance. Now with all of that data, we now have the ability to now build up the bottoms-up inventory. So the company, information, facility, well, information, equipment group, equipment, emissions that are coming out, type, date, quantity, duration, measurement method, the throughput, and everything to build that up. And these tables can be then used for these different inventory. But then on top of that, we can summarize that data, and which we do on the blockchain, and I'll talk about that. So we can provide that summary data. And so this, what's really different, you guys can speak to this, but typically what was happening before, let's say engineering used ProMax, they used it by themselves, and that was that. But now, HSC is involved with the data coming out of there, Ops is involved, and I'll show, Jason, you can watch the example I've got on that. And now sustainability. So it's created this interesting feedback loop where you can all look at the data. I don't know, you guys want to comment on that?
Yeah, from my vantage point, I mean, the biggest thing of, now we're able to go back to engineering and have those conversations around what is the best, in the design phase, what can we do differently, and where are there places where we can improve? In existing equipment, it's what can we optimize in that as well, and so working across the aisles and with different groups to really refine that down. And you can see it here, kind of a case study in that. And when we first started and turned on the system, our ProMax model came out with a methane intensity for the site that we were piloting this on at a 0.09%. And then we looked at the model and started looking at where were the drivers were really trying to put, using the data now that you had it and you could measure, which is usually the first step in any continuous improvement project, is measuring your process. Now we had this measurement that we could look at, and the data that we could then comb through and find that we had, too much capacity. And so by consolidating and bringing down some of that and consolidating some of our equipment, we dropped it a little bit more. And then also looking at how optimal were those pieces of equipment running, in this case, the dehydrators and the pump strokes on the pumps. That was a major driver, and we had a set number in there, but when we went out and studied that, we realized that they were running at a much lower rate than what we had originally put into the model. And we're able to then refine that even more. And the next step is, okay, how do we turn that into a real-time monitor and get that IoT data coming back from those strokes and put the actual data in there, which I think would, speaks to this concept called fidelity, which is, how confident are you in the number that it's producing or giving you, and that driving that, lower and lower will give you, you're driving out a lot of the uncertainty.
Mm-hmm. So this gives you an idea other ways, right? So real-time operations. So now this daily feedback, instead of having an emissions inventory, let's say once a year, you're getting the effect of being able to see what a site is doing on a daily basis and literally feeding back and saying, hey, what can we do to improve that? You're getting that data built up for a real-time emissions inventory, and then site and source level reconciliation. So adds, more capability. Where we're going is to build up an emissions inventory, again, that's common across all of these different stakeholders. So build up that data so it could be used for OGMP or, the Subpart W, or in their case, like Wyoming, investors may want to see some stuff. Who knows? If you're a publicly traded company, you got to actually report your climate risk numbers. And then the buyers who say, well, wait, if you can actually prove your method intensity, we might be willing to pay, a premium for that. So that gets to the monetized side. And so we can take this data and we create an NFT, and we actually have NFT that will produce at an MMBTU or a whole day's production, or even roll that up to different increments like that. So this is literally, you saw that the data required for a mass balance. So you're going to see some of the same meter data that's in here. And then it has in here like, hey, did you see an OGI detection on that day? We compare the actual sales meter with a virtual sales meter to say, hey, what percent difference were we? How confident are we? And it all boils down to, a methane intensity. We even put a part of the data fidelity in here for when was this meter calibrated within a certain number of days? Okay, so we make sure. Anyway, the big idea is to build up all the data you need to prove that methane intensity. And the way it works too is we have all this data that's private to the operator, the raw IoT, the raw visual data, the reconciled emissions inventory, and then we have a system to create that NFT, and we're building up systems to create the regulatory reporting. We are going through an ISO audit, and the reason why is we're helping PureWest with a particular transaction, and I wasn't there in the beginning of when this was a possibility, but you might want to talk to it as much as you want to share anyway.
Sure. Let me take a step back and just talk about the differentiated gas market in general. So what we saw a couple of years ago when we first jumped into this space is it was really focused on certification and getting that third-party audit. Things have really shifted since that time, and it's really all about the MMRV and proving out what we've got. And so that's the first thing to understand about the differentiated gas market. Utilities are facing a lot of headwinds in terms of procuring this gas, but they're working on it. There are industrial manufacturing who are taking advantage of some of these things. And, we're keeping an eye on things like the European Union, methane regs that are coming out, the CBAM, all of those type of things. And that's where this ISO becomes really important. Having an ISO verified product really just opens some more doors for leveraging the natural gas that's resulting in products going to Europe and things like that.
So what the audit allows us to do is, like I said, so we have this particular standard that we're doing that essentially allows PureWest to prove a low methane intensity feedstock. Now, what problem does that solve for then the buyer? Okay, well, there are petrochem buyers who may be required or may want to differentiate their product, okay, to sell it for methanol for transportation fuel or hydrogen or for LNG or whatever, and they're required to, if they have a greener product, to prove that it's greener. Well, what has been the feedstock before? Well, it's renewable natural gas, landfills, cows, whatever. That's expensive gas. So this other new standard says, hey, if I can prove empirically that it's lower, I can actually use that as a new feedstock, which is dramatically lower cost and dramatically higher supply. So it has potential to really transform the industry. But in order to do that, you have to get this ISO 14067, and then we have a third-party auditor who uses ISO 14064-3 as the methodology to audit us, and we're going through that as we speak together. Now, what that allows us to do then is to take those NFTs, and we have a marketplace on there so that the buyers and sellers can essentially sell an emissions commodity. So anyway, that kind of sums up. We didn't talk a lot about the WEC fees, but we're actively working on that. And, there's some interesting challenges that will come with that because, like I said, there is no, when you turn in your Subpart W as part of your WEC report, and they say, hey, we can audit you, but there's no standard yet. And like, audit it to what standard? So anyway, we're working through all that kind of stuff there. So anyway, we'll stop there, and we have, if there are any questions out there, love to field those. Let's see. You can put them in the chat or the Q&A. I don't see any right now. I'll tell you one thing that we're doing and why we created this is we're on this journey together with PureWest and helping them get there. And there are several our clients who are also making the empirical journey. And we know that it's, kind of it's a scary choice, right? Are you ready to go empirical? But instead of just saying going down the rabbit hole by yourself, we're saying, hey, we could come alongside you and help guide you. And one of the great things about PureWest is they've done these webinars, but they're out there talking about this and willing to also be helpful in this as well. So if you're ready to explore empirical, we have sort of next steps for you. Okay, so you can contact Nathan Merrill, his email. We'll schedule an empirical strategy call. And then depending on who you invite from your company, we're going to put together a team to help you include, including the people in this webinar. But these are the kind of people that we started putting together to help PureWest. So we have a chemical engineer, who these guys know who I'm talking about. We have maybe our data scientist. We have an automation engineer, Ryan. We have a brand new ProMax consultant, plus Justin Slago, plus Diego here. We have a combustion engineer coming from a relationship with Cimarron. We're now become tokenized energy engineers, regulatory compliance specialists, direct measurement equipment engineers. There's another equipment company that wants to partner with us, and other operators who are ahead of you on this journey. So if you decide you want to take this leap of faith, just know that there are people gone before you, and we're figuring this out, and we're willing to basically share what we've learned over the last 3 years to help you get there. Because honestly, the more people that go this route, I think it's going to be better for the overall industry. So
There's a question, Mark.
There's a question I see. Let's see. Is it in the chat or in the Q&A? Or
Ryan has raised his hand.
Oh, he's raising. Oh, he wants to ask. Okay. All right. I just allowed you to talk there, Ryan.
Hey, thank you. Good afternoon, everyone. Yeah, I just had a quick question. We're starting looking to this empirical side as well. Maybe, you guys could speak a little bit to the best way to scale empirical testing, right, for our whole field or assets or our basin, right? Because talking about cameras on location, does that more lend itself, cameras every location, or does ProMax kind of fill in some of those gaps with the 6.0 stuff?
Yeah, great question. And we're actually have been working through that and in the middle of, figuring a lot of that out. But where we've landed so far and what we're seeing in some of the things we've done is you can, doing the simulation of all the sites, gives you that. But if you take it down to the specific sites, or even in our case, specific designs we have different, what we would call vintages of equipment across our field. And so, factoring in those models or those simulations of those are more alike to each other, and studying the inner workings of those is where I think we're going to figure out that risk-based approach to where we put monitors, because then you can get that where you start to see anomalies, you can start to prove, ahead of time. So if you start to see a gas release from something, you go back and look at the data that you were collecting on those real world, on that IoT data coming in from all the sensors, and you can start to see the anomalies forming before it actually creates an event. And so monitoring that way through the data, where you verify by the cameras or by the other types of top-down sensors, I think is where that real breakthrough is going to come for us, and I think others, is that it's not, you see it more in the data beforehand than what happens afterwards. It's already happened. This is getting more proactive instead of reactive in that process, and that data really is, I think, going to be a key part of that.
Yeah, across other operators, it seems that they're sort of dividing their fields into 3 tiers. So you got your top producing sites. Maybe they're also sensitive because they might be close to a community or whatnot, and under a lot more higher regulations. So put our high-end camera system. So we have 3-tiered camera system. Then I've got a site still producing. It's pretty good. I put my methane-only camera on that in a autonomous fashion. Then we also have a handheld that's we call a hybrid because it's a smarter camera. It ties in with the other two, and that takes care of your legacy. So we don't know exactly what percentage. It may be 10, 10, 80 or whatnot, but you know, and then you have the proof zero sort of measurement on all the sites, you know, which again is the ProMax and tying in with the IoT devices and stuff like that.
And from a cost perspective, the ProMax is cost effective. You know, we're rolling it out into the entire field, and as Jason mentioned, it's really going to serve to inform, you know, the variety of tech. You know, even in our field, that's a consolidated field, we know that it's not one size fits all. And so what the ProMax does, it just enables us to use so many different technologies that we couldn't use before.
Yeah, it's kind of a both and. It looks like I think ProMax when you combine it with measurement is just multiplies the power of the tool itself. So yeah.
It's awesome.
Let's see, any more questions out there? Let's see. I don't see any. Yeah, I could talk a little bit too about, you know, some of the things that we're seeing. So on a little roadmap here. So mapping a site, when we first got into this, it takes a long time. I mean, you know, we've got our PhD chemical engineer, and she's working on this stuff. She's mapping them all. And but we're actually integrating our digital twin system with ProMax. So our goal is that a non-engineer will be able to set up a measured site in 4 hours. Now, notwithstanding the fact that, you know, sometimes it's harder for operators. Hey, give me those, you know, PNIDs, give me so I can tag that stuff, make sure the meters are calibrated. There are certain things that the customer can do on their end, and there are certain things we could do on our end. Subpart W and WEC hasn't been specified an audit standard. I do see some of the stuff from MMRV that will actually start to go back to here, hopefully. OGI quantification, people ask us about that all the time. And again, we have a bunch of early adopters who are providing additional controlled release training data. We've married it with mass balance to improve accuracy, and we're integrating it with our digital twin so the camera knows what it's looking at, right? It's not just say, hey, there's a blob, an image, and it's leaking. It knows, hey, that's a tank. Here's what that tank's supposed to be doing. Here's the actual gas that's coming out at that point. So cameras and detection and quantification are going to improve pretty rapidly with the AI training models and computational speed. The other thing is sites vary with direct measurement. And so we mentioned this concept that we came up with called the data fidelity score. So it provides an at-a-glance look to determine how empirical a production site is. So these are some of the things that are on our roadmap. Okay, well, if there are no more questions, any last thoughts? Jason, Kelly, on your journey here?
No, you can find us on LinkedIn. If you have any follow-up questions from a PureWest perspective, don't hesitate to reach out.
Oh, let's see here. Ricardo raised his hand. So, Ricardo, you're up.
Well, just to mention that the chat was enabled. That's the reason I was trying to send a message to the team. But thanks for the presentation. I will follow up certainly with ProMax with Diego. It's an interesting mix of this area and the process side, which we've been looking for. So looking forward to talk to you, Diego, about it. Thank you.
Excellent.
See you soon, Ricardo.
All right. Okay. Well, listen, I guess if the chat isn't open, is the Q&A open if you had any questions? You can always pop something in there. All right. Well, with that, looks like we got
risks exist
All right.
for operators?
Yeah, what risks exist for operators whose facilities are not ready for empirical calculations? Now, that would be interesting. Like, I almost want to ask, what makes them not ready? Meaning they have like 0 devices on to measure, or what makes them not ready?
I think that's where you can roll into the fidelity score. I think at any state you could probably roll out the empirical, just may not be as informed, or as the bands of uncertainty are are going to be wider until you get more of the direct measurement of certain parts of your process. But I think it'd be interesting to see what that would look like out of the gate for something that didn't feel like it was ready.
And I would say, like, any kind of facility, modifications obviously need to happen first if they're already planned. But in terms of being ready, Mark, maybe you can talk to this. But if you've only got like one sensor or no sensors or whatever you've got in SCADA will improve those fidelity scores, but they aren't needed. They aren't mandated. You can put in factors and assumptions and build the fidelity over time.
Yeah, I mean, we've used it where we plugged in literally our camera as a device to fire up the ProMax model, so you can even use that. So I think we're pretty good on the measurement side. If you're asking this question from a more 50,000-foot view, what if we as a company aren't ready to go empirical? I mentioned some of the risks, which is WEC fees. Paying taxes.
I think that's probably the biggest risk we're all facing are those WEC fees.
Yeah, really pay attention to that right now, because it definitely caught us by surprise as far as just the magnitude of the change in some small areas that are going to really drive those numbers a lot higher.
I mean, the other risk might be that if a market, if the market matures, evolves, and buyers get used to the idea that empirical gas is available, they may put out a request, hey, I'd like to do, but empirical gas only. And so the downside would be that your product isn't as sellable.
Yeah, you're missing out on the opportunity cost there. First of all, it's the WEC fee. And second of all, oh man, now we can't even sell at a premium, even though, the WEC fees aren't a problem anymore. So, yeah.
Well, and I think if we take a step back and forget about all the regulations, I mean, the real value in this from an environmental perspective is being able to really come up with mitigation strategies that mean something, that are real, and having that real data and real understanding of where you're starting from is the only way you're going to get there.
Yeah, I think the other risk too, because Jason, I'd love to hear your thoughts on this. But so I'm watching different clients, right? So you guys have done this empirical deal. Now you're getting actual data you can make decisions on, like you showed on that slide, right? And then there are other people who are making, very significant decisions, but they don't have any empirical data. So they're literally making decisions to improve their sites off of the factor data. The question I would have is, what would those two things look differently?
You're going to prioritize definitely differently based off one or the other. Are you playing the Subpart W game of buying the assumptions that EPA has made about very regional performance of different components and applying those, which may not have a real world effect if you really kind of boil it down and really think about it. But so are you really making a difference, or are you just going off of the numbers that they're providing you?
Yeah, it's basically, hey, take the number. And you even mentioned even Wyoming's emission inventory, how you give them your, throughput, and they tell you what the emissions are. I mean, that is the classic, just plug yourself into the matrix. We'll tell you what to believe, and that's all good. Or you go the other route where you're actually making, improvements based on actual empirical data. So.
I can prove it and defend it, right? That's the other piece. We can show you through the process what's happening and can go back and point to exactly where the changes occurred.
Okay. Well, that was a great question. And I don't see any more questions. So with that, I want to thank the panelists, Jason, Kelly, Diego. Thanks for being here. And thanks for really, I think, trying to help lift the entire industry up, really, because I think you're getting the sense that it's time, it's time to move to empirical. And because of guys like you, your companies like you're pioneering the way, and you're willing to share what you've learned with those people who are just starting the journey. So I really, really appreciate.
Thanks for the time, Mark.
PureWest, yeah.
Thanks, Mark.
Yep.
All right, bye-bye.
Bye.